We are going to solve polynomial equations. The degree is the number of roots. The roots could be real number or they could be imaginary numbers. To solve the polynomial equation, we're going to write it to make it equal 0. So wherever the polynomial function is, it's got to equal 0. And then the second thing we're going to do, we are going to factor. And here's our steps for factoring. First, we're going to find the greatest common factor if it exists. And then we're going to factor it. We're going to try unfoiling. And if we factor it and we can't find the solution, we're going to use the quadratic formula only if our degree is 2. In problem number 1, we're going to solve the polynomial equation 2x cubed minus 5x squared equals 3. First thing I need to do is to make it equal to 0. So I'm going to take the polynomial equation. I'm going to minus 3x from both sides. So then I get 2x cubed minus 5x squared minus 3x equals 0. My degree is 3, so I have to have 3 solutions here. So I'm going to look at each term to figure out if there's a greatest common factor. So I look at the 2, the 5, and the 3, nothing comes out. But I notice they all have at least one x. So my greatest common factor, I can divide them all by x. So I'm going to divide them all by x, so x comes out. And then 2x cubed divided by x is 2x squared. And 5x squared divided by x is 5x. 3x divided by x, those x's cancel out. So that equals 0. So I am going to factor. What multiplies to 2x squared? That's easy. It's 2x and x. What multiplies to negative 3? It's 1 and 3. But I don't know. I'm just guessing that 1 goes here and 3 goes here to give me negative 3. I need to check the middle because my coefficient of a is not 1. So I have 1x. Then I have my outside term minus 6x. These two add up to negative 5, so it is factored correctly. Now find the solutions. If I have x by itself, x equals 0 is the solution. So remember at the beginning we said cube. We're going to have 3 solutions. There's 1 solution. I'm going to cover the 2 right here. Pretend the 2's not there. X would have to equal negative 1. So then I'm going to divide by 2. So I got negative 1/2. And then what makes this 0? When x equals 3. So here's my 3 solutions. I got 0, negative 1/2, and 3. To check them, plug them into the original equation. So the first thing we're going to do in B is we are going to make it equal 0. So I am going to subtract 6x cubed. So when I subtract 6x cubed, I need to put this in order by degree. So I have 3x to the 4th minus 6x cubed, because it needs to come before the 12x squared equals 0. So the next thing I need to do is find the greatest common factor. So I look at each term. 3, negative 6, and 12, they all have 3 in common. And then I notice I have x to the 4th, x cubed, x squared. They all have at least an x squared in them. So I'm going to divide them all by 3x squared. So then I get 3x squared, so 3 divided by 3 is 1. X squared divided by x to the 4th divided by x squared is x squared. Negative 6 divided by 3 is 2. X cubed divided by x is x. 12 divided by 3 is 4. The x squares cancel each other out, and then I get 0. So I want to solve this equation. What multiplies to positive 4 and adds to negative 2? There are no factors. So because it's squared, I'm going to use the quadratic formula. Because I couldn't factor it. I would prefer to factor it, but can't be done. So we tried to factor it. It doesn't work. So we're going to use the quadratic formula. Opposite of b over 2a, that's the axis of symmetry. And then the discriminant, b squared minus 4ac. So I need to have 4 solutions here. If I have 3x squared, what makes this 0? 0 does, right? That's 2 of the solutions. And then I need to label A, B, C. So I have 1, -2, and 4. I am going to plug it into the equation. So the opposite of b is 2 over 2a. I'm going to do b squared, which is 4, minus, it's always 4, times a times c. So I have 2 plus or minus the square root of -12. Square root of -1 is an imaginary number. That's why we can factor it. So when I go to factor this, I'm going to factor 12, -1 times 12. 12 is 4 and 3, 2 and 2. So I have a set of 2's that come out. So I get 2 comes out. Square root of -1 is the imaginary number I. And the square root of 3 never came out. So I get 2 plus or minus 2i square root of 3 over 2. So I get 1 plus or minus I square root of 3. That's 2 answers. And then this is 2 answers, so that's a total of 4 answers. So in problem number 2, we are going to solve by factoring because it says. If I didn't use factoring, I would use the quadratic formula only if I had the second degree. If I have any other degree, quadratic formula does not work because quadratic is only for the second degree. So I have x to the 4th minus 3x squared equals 4. First thing I need to do is to make it equal 0. So I am going to subtract 4 from both sides. So I'm going to use what I like to call the quadratic method to factor this. Because I have x to the 4th. So x to the 4th, what multiplies to x to the 4th? It's x squared and x squared. So I have x squared times x squared is x to the 4th. Two numbers that multiply to -4 and add to -3, I have 1 and -4. I'm going to check the middle to make sure that's right. -4x squared plus 1x squared is -3x squared, so that is correct. So I want to find the solutions. I need to have 4 solutions because my degree is 4. So x squared, it's got to equal 4 because 4 minus 4 is 0. So I'm going to go x squared equals 4. Square root of both sides, get rid of the square. Square root of 4 is 2, so I get plus or minus 2. That's 2 solutions. X squared plus 1, it's got to equal 0, so I'm going to make it -1. -1 plus 1 is 0. So x squared equals -1, square root both sides. So square root of -1 is I, so I get plus or minus I. Now that's 4 answers. This is 2, 3, 4. In problem B, we are going to factor a perfect cube. I have x cubed equals 1. So here is a list of some of the perfect cubes. If I go 1 cubed, that equals 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. And here's a list of some more perfect cubes. So when you do these problems, if you recognize the perfect cubes, it's so much easier. So I'm going to do the same steps as I did in the previous problem. First step, get it to equal 0. So I am going to minus 1. So minus 1 from both sides, and I get x cubed minus 1 equals 0. 1 is a perfect cube, that's why it's on this list. Now, a perfect cube factors into a binomial and a trinomial always. So the cube root of x cubed is x. The cube root of 1 from this list, we can see it is 1. So that's my binomial. to get the trinomial, I am going to take my first term right here, x squared, and square it, x squared. To get my middle term, I take my binomial and multiply together. X times 1 is x. And then I take my last term and square it, is 1. So I squared my first and last terms, and I multiplied these two together. When you factor a perfect cube, like this problem, you always get a negative. If my negative is right here, it becomes in the beginning. Otherwise, that's a positive. If this is a positive, that's a negative. You have to have one negative. And it equals 0. So let's just review that. I took my first term and squared it and wrote it here. I took my last term and squared it and wrote it here. My middle term is always this number times this number right there. But the sign, if this is negative, I start out with a negative, that's a positive. If this is a positive, then this is a positive, and that's a negative. To figure out my solutions, my first term, what makes that 0? 1. So x equals 1, because 1 minus 1 is 0. My trinomial, you'll never be able to factor that. So you just use the quadratic formula. So my a is 1, my b is 1, my c is 1. So I'm going to plug it into the quadratic formula. The opposite of b is negative 1. Then I have 1 squared minus 4 times a times c. So this is what I get. So here's 2 answers. Here's my other answer. So that's a total of 3 answers because I had x cubed. In problem number 3, we're going to find the solution, the real solutions, by graphing, because the graph will not show you the imaginary solutions. So in this problem, I have x cubed plus 5 equals 4x squared plus x. First, I have to rewrite it to make it equal 0 as my first step. So I rewrote it, and here it is, x cubed minus 4x squared minus x plus 5 equals 0. And then I'm going to put it in Desmos. And in Desmos, I got this graph. And if I click on the solutions, if I click on these points, it tells me all 3 solutions.